So today I had some questions about patterns and how to do these types of questions. So there's a couple of different types of patterns. There's just any old pattern, you know, it doesn't have to stick to one thing. And then there's something called specifically a linear pattern. So I started with just any old pattern where maybe you're going to be adding numbers, maybe you're going to be multiplying, maybe dividing, and we have to figure out from the question which one it's going to be. So this one says the ice cream shop sells one cone for $3.50, two cones for $6.75, and three cones for $9.75. If the pattern continues, how much will it cost for 4 cones?
It looks like they're adding $3.25 each time.
Okay, well, let's check. If we did $3.50 plus $3.25, we think it's $3.25 each time. Let me pull up a calculator.
Well, the last one might not be $3.25. It might be something different. I know the first one would be $3.25.
Okay, so 320 plus 3 or 350 plus 325 is 675. So the first one is 325. What about the second one?
The next one, they're only adding 3.
Only adding 3. So 675 plus 3 gives us the 975. So we figured out the pattern. Now we kind of have to figure out a new pattern. Sometimes you have a pattern within the pattern. We have to figure out, because they want the 4th cone. We want one more.
Yeah, so you got to figure out how much it's going to cost for 4 cones.
So what was the change between the 325 and the 3? What happened that was different between them?
You had to go up. They added cents to that. 325.
Okay, so 325 is more than 3 by how much?
By 25 cents.
By 25 cents. Now, we are going top down, so 325 minus the 25 cents to get down to the 3. So on the next one, I said plus, but actually it's going to be minus. So if we subtract again, we are going to subtract the same amount. And I put that in the wrong spot. Sorry, let me put it over here. So we are going to subtract 25 cents from 3 to get what we do add next. So you have to keep track of, well, am I subtracting or adding? Which one is happening where? So we're going to add 275 more.
3, yeah.
Well, not to the 3. What number do we add the 275 to?
Oh, to the 9.
To the 975.
Yeah. I got confused for a minute.
So let's plug that in. So again, I'm pretty sure this is the calculator you'll be using. I think it helps to leave each actual thing you type in up so that you can keep looking at it. But if you want to get rid of them, you can X out of them. So the 975 plus 275 is 1250. And that is for 4 cones. So we answered the question. We always want to check, did we answer the question? So we answered the question. For 4 cones, it costs $12.50. And we did have one more student join. Thanks for coming. If you want to ask questions or answer any of the questions, you can either unmute your microphone or type into the chat box. We'd have to click on, for me, it's 3 dots. Sometimes you have to kind of move around to figure out where the chat box is, but that's optional. If you just want to listen, that's fine too.
Oh, there I go.
So new pattern. Carlos is saving money to buy a car that costs $1,800. The table below shows how much money he has saved up by the end of each month. So by the end of January, 200, end of February, 4, March, 6, April, 800. By the end of which month will Carlos have enough money to be safe? So most of the time with these table type questions, it's good to just write them out and keep continuing with the same pattern.
I have to log back in again. I clicked something.
Okay.
But I can't see the thing. Oh, there it is. Okay.
Okay. I was going to double check and make sure I didn't mess up anything.
Oh, wow, that's too big.
So we need to figure out how much he makes the next month in May. So what's going on for this pattern? How much does it take to go from 200 to 400 or 400 to 600?
200.
200 each time. This time it never changes. We add 200 here, added 200, 400 plus the 200 gives the 600, 600 plus 200 more gives the 800. So now we do it again. We add 200 to the 800. So what number comes next?
10, well, 1,000.
1,000, yep. So by end of May, he has $1,000. So again, we have to make sure we answer the question. The last question, they just wanted the next one. But the question here is, when will he have enough money? So does he have enough money?
No.
No, we got to keep going. It's got to have 1,800. So we just keep doing it. And I literally just, I'm sure you'll get some sort of scratch paper allowed. I literally just keep writing it out. If I try and do it in my head, I'm going to make a mistake and miss something. So it
Yeah,
can
it's
be,
not going to be enough either.
no, not enough either.
July.
1,400.
Yep, July takes us to 1,400.
And then August will be 16. September. No. No, it's going to be October. No, I was right. September.
Yeah, September.
Yep, September. He'll have exactly enough. Now, if the table had been like, we only made it up to 1,700, and then we go to October and we're 19, we're over, it still has to be the over amount because you still can't buy it if you don't have that extra $100. So that was September. And again, always make sure you answered the question. September is when he has enough money saved. They love to give you questions where maybe you think you're done, but you're not quite done. So always refer back to what it actually want.
I have one question.
Mhm.
It's not about the problem, but it's about when you go to do the test.
Mhm.
What part of the building do you have to go into?
I have no idea. That's a question for Amy Wright. She's the testing coordinator. So she'd have to look up where you're testing because everyone has a different testing site.
I got to go to North Canton.
Yeah, still no idea. That's what Amy is for. So you can email her at amy.wright@graduationalliance.com and she can help you with that. I am not sure at all.
Okay.
Okay. So next pattern. We've done a lot of adding. This one's going to change it up a little bit. A biologist is researching the growth of a certain species of bacteria. He initially starts with 200 bacteria. So the starting amount is 200 and determines that every 2 hours, the amount of the bacteria triples. How many bacteria will be present after 12 hours? So lots of key words here, but we also need to know when it says the word triples, what math is it actually asking us to do?
Multiply.
Multiply by what?
2.
Okay, we have one answer of 2, one answer of 3.
Well, you need to know how many bacteria every 2 hours. So you're going to have to multiply it by 2.
But that's not the thing that's telling us to multiply. The word triples is the word telling us to multiply.
Okay, yeah, by 3 then, triple. 3 is triples.
Try like tricycle. So initially starts with 200. Again, we're kind of want to make a table and just see what happens as we go. So an initial starting amount, that means 0 hours have passed. No time has passed yet, but we have 200 bacteria. So this is where the 2 hours come into play. Now we say, well, 2 hours later, something happens. What happens 2 hours later?
It triples. The bacteria is triples.
Triples. So what number of bacteria are we up to?
3. Well, 6.
600. 200 times 3. And again, this is where, so this, I'm pretty sure they changed a whole lot of stuff. So I still keep trying to double check, but I'm pretty sure everything I know is you'll be using this calculator or a version of it. It's online. So when you type it in, you can type it in and then keep it up. Instead of erasing it, just click on the box below. And now we do it again. 2 hours later. What time are we at 2 hours later?
Okay, you got 3 times 3 again. So that's 12.
Okay, so we kind of have two things going on here.
Wait a minute, 6 times 3 is 18, not 12.
18.
So 1,800 bacteria, but what happens with the time? What time are we at when we have 1,800 bacteria?
3 hours later? No.
How many hours did the bacteria have to have in order to triple?
2 hours later, so it'd be 4.
So 4 hours later now. And we got to keep track of that too. So we actually have to pattern both sides. We're adding 2 over here each time. We're multiplying by 3 each time on the other side. So I want you guys to finish up the problem. How many bacteria should we have after 12 hours?
Times 3. Okay, I'm about to get some paper for this one.
Yeah, and it might take a minute. I mean, it's a long time. It takes a little bit to go through the pattern.
Okay. So, 18, gotta times that by 3. That'd be 6 hours right there. That's 54. Okay, it's 8. Times 3. Times 62. It's 10 times 3. $48,600. 12. Okay. Times 3. Okay, it's going to be 14,580 is what I got.
Okay, so one answer. Let's see what our other participant got.
Mm-hmm. I'm still, I gotta do it one more time.
Okay.
0, 0, 6, I'm trying to think that's 3 times 6.
Actually, I may be wrong. Hold on.
Okay.
0, 0, 18 for the 1. Okay, I got 14,000. Well, Actually, it'd be 145,800 is what I got.
Okay, so
145. Where having a brain fart. Okay. Oh, yeah. Is it? Oh, I don't think it's C.
so you think it's also C?
I said I don't think so.
I know it's C. I did it over again.
Um, might be C.
I think your connection isn't super good because I can't hear what letter you're saying.
He said it might be C.
Might be C.
Yes.
Okay. So
I feel
again,
like it's triple. I feel like it's higher than that, though.
okay. So all of the answers are numbers you will see when you're multiplying. Well, let me type it out in here so you can see what's going on. 1800 times 3, because if we have them all up, we can see 16200. So you think it might be D then? You think it might be the one higher.
Yeah.
And 145. So notice 145800 did come up. If we do it one more time, we do also come up with that last number. So how do we tell which one? They're both possible answers. They're both one of the things that happen when we multiply by 3. And that's where the amount of time comes into play. We had to get it exactly at 12 hours.
And then that shows your 145,800. Exactly at 12 hours.
And you are correct. It is the 145,800, but let me show it as well. So 2 hours, you started with 200 bacteria. I guess maybe I'll write it above. 4 hours, you had 600. 2 more hours later, that takes you to 6 hours. 2 more hours later, that takes you to 8 hours. 2 more hours later is 10.
And then that's 12.
Oh, I did something wrong. This should have been 0. Sorry, I had it offset. 2, 4, 6, 8. This one's 10. This one's 12.
Yep.
So that's why I actually recommend like just literally writing the entire table. I know it's tempting to just do it in your head or have the calculator, but it's easy to lose track of where you are on that list and know where to stop.
And then you might get the answer wrong.
Yep. Because they really, really like to give questions where you might do something just a little bit different and still get that answer that's on their list. It's just not the exact answer they're looking for. Okay, so another pattern, but this time they're relating it to an equation. The table below shows the values for a function. Which equation represents this function? So a function is a special type of math equation you can work with, and it has a lot of super special properties. Even though you may not know exactly what the word function means, it's not actually super important. What's important is being able to look at this equation and relate it to this table. So it's really, really hard to do this question by only looking at the table and trying to get the equation. The easier way to do this question is to take each answer choice one at a time and check it to see if it makes the So we're going to look at answer choice A first. We don't know if it's right, but we're going to look at it. And again, you may not be super familiar with this f of x notation. It's a fancy way of saying y. F of x is basically the same thing as the letter y all the time. Like that's just a common thing. So what we can do is we can take the x values of the table and plug them in to see if we get the correct corresponding y values. We want these numbers, the 1, the 7, the 17, we want them to come out. So we take the letter x and we replace it. And again, we have to do this one at a time. We're checking each of the possible numbers in the table. So what's the first x value on the table?
1.
1. So that's the first one we're going to try and see if it comes out with the correct y value. So when we have 1 squared, what is that actually telling us to do?
1
Multiply.
times 1.
Multiply, and specifically multiply 1 times 1. So you were both correct. So that equals 1. Is that the answer we wanted for the y value?
Yes.
So that worked. We've got to make sure they all work. They might have one where it works for the first, but not for the next one. So now
It's definitely not working for the next one.
why not?
Because you're going to have to do, for the next one, for the x value would be 2. You're going to have to do 2 times 2, and that's going to be 4.
Didn't work. Answer choice A is not our answer. So now we try it again, but with answer choice B. And instead of writing f of x, I'm going to just switch it to y right now. So this time we have 2x squared. The number 2 is next to the letter x. What math operation is in between? Is it 2 plus x, 2 minus, 2 times, 2 divide?
2 times.
2 times, yep. So 2 times the x squared. And then we've got to take the numbers one at a time and plug them in again. So 2 times 1 squared, because we're going to go start at number 1 again on the table. That, according to order of operations, should we do the 2 times 1 first or the 1 squared first?
1 squared first.
Good, 1 squared first. And the 1 squared is really 1 times 1, which is still 1. So then what number do we get out at the end?
2.
2.
So did that work? Is that the number we wanted?
No.
That ain't even close.
Nope. Didn't even work the first time.
So
So-
A and B is out.
Yep, A and B is out. So it's kind of a long process, but even though it's a little time consuming, you have plenty of time on the test and it's way easier than trying to figure it out from the table. Whenever they give you functions and a table, it's best to just use the table itself. So then 2 times x squared plus 1, we plug in 1 again. What do we get if we simplify all of that? What's the final number?
Okay, well, I'm going to have to do that.
Is it 5?
2 times
Okay.
1.
I can see where you got the 5 from, but 5 is incorrect. Remember to do your squared first.
Oh, that's
then-
okay. All right.
3.
It's 3. It's a super common order of operations because the way we read is left to right. We always do everything left to right except math. So be careful with your order of operations. Okay. So then is C our answer?
Nope.
Nope, it ain't close either. So
So
it have
that-
to be C.
Gotta be D.
Has to be D. Now, if you're unsure, you could either go through the process again and double check, or you could check D out. You could plug the numbers into D just to be like, okay, I didn't make any mistakes with A, B, and C, but you guys are correct that D is the answer, so we'll skip checking it over. So next one, and this is the last general pattern. After this, we're going to talk exclusively about linear patterns. So this one, a rabbit Sorry, say that again.
I never heard of linear patterns.
It'll probably seem familiar even though you don't recognize the name. I think you'll recognize the actual process of doing it. Just, I always call it the fancy math name.
Can I got a question.
Yeah,
Are we gonna go over the ones like you have to write in the answer instead of it's not multiple choices, like you gotta write like an essay with math question, like show your work and all that?
We can. I'm unsure of how they're gonna change that since everything is on the computer now. There's no more paper tests. It's all digital. So they've taken down a lot of the information, but I'll make sure to include, and we might have some time today to just go pick one at random.
Okay.
But I will make sure.
I think I got a 391, and I think if I wouldn't have those questions, I would have asked.
Yeah, that's so close. That's almost there. Yeah, so if we don't get to one today, I'll definitely include some next time, and I'll make sure to include more as we go.
Okay, thanks.
So the rabbit population in a forest area doubles monthly. There's a key word again.
Whoa.
The first one, oh, yep, that is multiply by 2. Just like triples was times by 3, doubles is still multiply, but by 2. The first month, there are 150 rabbits. So first month, 150. If M represents the number of months and P represents the total rabbit population, which equation models the situation? So without even like worrying about the numbers, the letters can actually eliminate 2 of our answers. It's either got to be P equals or M equals. So the letter on the left that's alone, that should be the letter that tells us the total amount of everything. So which one represented the total? The months
It would
or the
be
population?
Pretty sure it would be M equals 150 times 2.
Okay. So M is the total amount. Is there anything in the sentence that talks about total?
Yeah, the number of months represents the total rabbit population, so it'd have to be P.
Yep, so P for population. So that left side should always be represented by the total. So you've got to go find, well, where's the word total? Or, you know, any synonym, any similar word to total. They could use any word, but whatever the total is, that should be our letter on the left.
What, P? Yep.
Yep, P for population.
So it's the first one or the second one that would be right.
So how do we know? Well, the only information we know is after 1 month, the population is 150 rabbits. We're going to try our answer choice. Sorry, they weren't labeled. We'll call it answer choice A and answer choice B. We're going to try our answer choice with the only information we know for sure.
Oh, okay, A.
Yep, so we're going to try answer choice A, and we're going to plug in the number of months and see if we get out the correct total population. So we know only the information for 1 month. And now we're stuck with kind of a weird order of operations issue because exponents come first, but there's stuff going on in our exponents. Both of this is exponents. So we actually have to do the subtraction first because they're both part of the exponent. Well, I added the parentheses in. You didn't see the parentheses.
You're bleeping out bad. I don't know if it's my earphones or what.
Let me just try bringing the mic a little closer. So I added the parentheses in because it's natural for me, but you would just have it written like this. So you have to remember, if there's a whole bunch going on in my exponent spot, you got to do any simplification in that exponent spot first. And is that any better? Can you hear me any better?
Yes.
Yes.
Okay. So we have to do the 1 minus 1 first.
Which is going to be 0.
Yep. So now there's another question. What's 2 to the 0?
0.
0.
Actually, it's 1.
1?
Yep.
Huh?
It's a really, really weird one. 2 to the 0 actually equals 1.
Oh, okay.
So if you're ever unsure, calculator. I'm gonna exit out all of these. So on this calculator, you can do 2, and then you.
Okay, you're going to subtract the 2 and 2. Make it 0.
Mm-hmm. We'll make it
Right.
1.
Yeah.
The reason 2 to the 0 is 1 is if you have 2 divided by 2, what is 2 divided by 2?
1.
1. Well, the rule of exponents is if they both have exponents and you're dividing, you subtract the exponents. 1 minus 1 gives you the 2 to the 0, but it's got to equal the same thing. If 2 divided by 2 equals 1, 2 to the 0 also has to equal 1.
Okay, I get it now.
So we still have to do our final step though. 150 times 1
Is 150.
So is that what we wanted?
No.
What did we want?
We want the exponent, right?
Well, we wanted a specific, we were plugging in a specific month, month 1, to see if the answer we got matched the correct population. What was the population after 1 month?
150.
150. So is it what we wanted then?
Yes.
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 Okay.
So let's say you're just confused by eliminating 2 of the answers at the beginning. Even if you're not sure how to do the rest, that increases your odds a lot. If you say, well, I know for sure it's P because P is the total, then you're only picking between 2 choices, and 2 choices means you have a 50% shot, even if all you're doing is guessing. Also, let's say instead of doing each step individually, you just want to plug this whole thing in. 150 times 2 to the 1 minus 1. You can do that in this calculator. 150 multiplied by 2, and then the AB button here makes it an exponent. And you type in the 1 minus, oh, it brought it down. Okay, what you do have to do is use parentheses. So you can type it into the calculator, but you have to remember to use parentheses, else it automatically goes back down. If you want something to stay in the exponent spot, then you have to put parentheses. But then it just calculates it for you.
But they want you to share your work, so you can't do that.
Depending on the question. The one we were on was multiple choice, so it doesn't matter if you show your work.
Okay.
If it was one of those short answer problems where you have to show your work, that's where you wouldn't want to just plug it into the calculator. Okay, so now this is exclusively a linear pattern. And linear patterns are always adding by the same amount. So we've actually seen one linear pattern before. It was the car saving one. We just added 200 every time. That's technically a linear pattern. So linear patterns are actually a little bit easier since they're mostly addition. So one section in a stadium has 32 seats in the first row, 36 seats in the second row, 40 seats in the third row, and so on in the same increasing pattern. Which equation represents the number of Y seats in row R? And I wrote all of the answers with the wrong letter. Those should all also be R's, not X's. So we want to know for which row, how many number of seats? So how many seats did we have in row 1?
32.
32.
Good. How many seats in row 2?
36.
How many seats in row 3?
40.
And how many seats? Oh wait, we don't have a row 4. Sorry, I was just gonna keep going. So how much are we going up by every time?
4.
4.
We are going up 4. 32, 33, 34, 35, 36. Yeah, 4 to count up. And it's going to be that same amount every time if it's a linear pattern. They're not always going to say it's linear. Sometimes they literally do. But if you add the same amount every time, it's linear. So there's a couple ways to then do this problem. You could do what we have been doing and actually just try each answer choice. Say, answer choice A, I'm going to plug in row 1, see if I get 32. Answer choice B, I'm going to plug in row 1, see if I get 32. Or with linear patterns, if you can remember how they're set up, it's easier to set up the equation. So for linear patterns, your total always equals the starting amount at 0 plus the amount you add every time times your variable. I ran out of room, so I'm just going to put VAR for variable. So if you can remember that kind of setup, you could just select your answer. One of the easiest ones to identify is the amount added. How much did we say is being added every time?
Plus 4.
Plus 4, and then it's times our variable, which should have been the letter R. I had originally had X's, but up here I said row R. So we know it's supposed to be plus 4R. What answer choices have plus 4R at the end?
A, B, C, and D. Well, no, just A, B, and C.
Honestly, A and C.
Okay. So definitely not D. We all agree it's not D because it was minus.
Right.
So in our linear pattern, there are no parentheses. I didn't say parentheses starting amount, parenthesis then variable, and it actually makes a difference.
So then C is not going to be it either.
So then C is not it. So it's either A or B.
A.
Okay, well, let's see. It says the starting amount at 0, and 32 is when you're on row 1. So that's why it's important to know the starting amount at 0, because we've got to actually go backwards. We want to go back to, what if we had a 0 row, even though logistically we would never have a 0 row. Mathematically, we have to do it this way. This way. So it's B, because we've got to go backwards.
Okay,
Backwards
yeah,
from
28
32.
plus 4.
Yeah.
It's 28. So 28 plus 4R. And then they used the letter Y to represent the number of seats.
Yeah, see, they make it tricky, so you don't get the right answer.
Yep. So again, if you don't want to remember, it can be hard to remember that. But if you can memorize this, it's not on your formula sheet, then you can do it this way. If you're like,
How do they give you a formula sheet there, or
now that it's online, I believe you'll probably just be able to pull it up. But if you want to look at it beforehand, I mean, you definitely will get it in some form or the other. I'm pretty sure it'll just be something you can click on the computer.
Oh, okay.
But if you want to look at it beforehand and see all the things on it, then you just Google Ohio OGT formula sheet. And it'll be one of the first ones.
This one is gonna be harder than the last test.
Maybe. I guess we'll see. It's hard to really know since they've switched things up.
I haven't even taken the test yet.
But all the new students have to do the EOC, so like all the kids graduating this year, and that test is just harder in general, so at least you get the easier version.
So my kids will have to take the EOC.
Yes. Yep, unless they change it by the time they graduate.
That's the harder one.
Yep. Okay, so next, linear pattern. Jane buys a car for $12,300. The value of the car decreases linearly. After 3 years, the car is worth $9,900. So she bought a car for $12,300. We're going to say times 0 because she's just starting out. And after 3 years, by the time we get to 3 years, it's $9,900. We need to know.
Decreases is subtract.
Decreases is subtract. Good. And then the word linearly actually tells us something important. So it could just decrease in any way. Maybe she went to 12,000 and then down to 1,300. Like there's no pattern, it's just going down. But when it decreases linearly, it has to decrease by the same amount every time. So we're going to have to decrease 3 times by the same amount every time and end up at 9,900. So for a problem like this, I think, again, it's easier to use the answer choices and just try them out. If we minus 800, where does that take us at the end of year 1?
Okay, 12,300 subtract. Gotta borrow. Oh, my pen ain't working. Come on.
Well, when pens run out of ink, we consult the calculator.
It's a brand new pen.
Okay, so it takes us down to 11,500.
500. Yeah. That's what I got. If my pen would work.
So that's the end of year 1. Now we do it again to get to the end of year 2.
Okay, so you need 11. Come on, pen.
So again, I consulted handy dandy calculator. Oh, and if you want more practice with Desmos, there's also an app. If you guys have smartphones, you can download the app and play around on the app. It works a little bit differently, but it has most of the same features.
Okay, what's that app?
Desmos, you would just
Okay.
search for Desmos. You could say Desmos calculator. And you want the graphing version.
So we got 500, 800. So is it 1,700?
10,700. You may have left a zero off or a one off somewhere.
No, it's a zero.
Yep. So 10,700. So then we check if we did it one more time, does it take us to the number we want? If we do 10,700 minus 800, do we get to the 9,900?
Okay, I gotta check that out. Yeah. I could tell already it's gonna be that. Because you gotta borrow again. Yep, 9,900.
Yep. So our first answer happened to be the correct answer. That can happen when you do this guess and check and you're like, yay, I'm done, instead of having to go through B, C, and all the way to D. So if you do want a second option, say you don't want to use the answer choices, a second option would have been to subtract the amounts that you're given. So this is the total. Sorry, it kind of went all robot-y again. I couldn't hear exactly what you were saying.
I heard that too.
I'm sorry, I still can't understand you. I don't know why the connection's so bad today. If you wanted to chat it instead, or if you want to try one more time, I apologize, but it's giving me robot voice.
And my phone's ringing. It can keep ringing. I'm busy.
So the second way to do it is to just subtract. So over 3 years, it dropped 2,400. And since it's subtracting by the same amount over all those 3 years, if you just divide by the number of years, that gives you the amount you're subtracting each time. So that's just a second way to do the same problem. Okay.
Yeah, that was me.
So next question. Hector and his friends went out for pizza. Altogether, they have $30 to spend. So that's total right now. The equation for the total cost of pizza and drinks is C equals 20 plus 2.5x, where C equals cost and X equals number of drinks.
Oh, I need another pen.
So what is the greatest number of drinks they can purchase?
I didn't hear that part. My earphones came out.
So what is the greatest number of drinks they can purchase? They have $30 total, and the formula is the cost is 20 plus 2.5x, where x is the number of drinks.
So they got
Okay, C's cost.
Sorry, I'm working from home today, and my dogs apparently heard someone. So, total number of drinks. And we have 2, 4, 6, or 12 to choose from. We want one of those to be the total number of drinks, keeping in mind they only have $30 total. So what do you think we should do to figure out how many drinks can we actually
divide
by?
2.5? No.
You could. So division actually works if you do one thing first. You're not dividing into 30 because you're not spending all $30 on your meal.
Right. You gotta include the drinks, right?
Yeah, we want just the drinks. So we've got to get the 20 out of there. We've got to take the 20 away from the 30 because we've already spent that. And then
So
you
got
can buy.
$10 left.
Yep. So then you can divide by 2.5, which division with decimals is hard. I definitely recommend doing stuff like that in the calculator. And so you'll notice it looks like a fraction, but fractions are just division. It's still saying 10 divided by 2. If you do 4 drinks. And I think your connection is better. Do you still have a question about the last problem that I missed because it was going in and out?
No, it's okay.
Okay.
I'll see. That's a good question.
Okay. So yeah, that one, this particular problem looks like there's a lot going on, but it's actually more straightforward. You could have also tried your answer choices again. A lot of the time, if you have an equation, you could say, well, let's try 2 drinks. 5 times 2 is 5. 20 plus 5 is 25. Well, I have more money. I can probably buy more drinks. And then just try each answer choice to find the final answer.
4. Is that what we got when we divided?
Yep. 10 divided by 2.5 is 4. They show the answer in the bottom right-hand corner.
Okay, I see it now.
Okay. So this next one is a linear pattern, but it involves looking and interpreting the graph of the linear pattern. So a hot air balloon starts its descent from 540 feet. We're starting at 540 and then descent. What do we mean by descent?
Believe. Far away.
Decrease, maybe?
Decrease, you're going down. The hot air balloon is going down instead of up in the air.
Okay.
So it descends, still going down, at a rate of 60 feet per minute. What does the point P on the graph represent? Point P is all the way down here. We're in our little hot air balloon, and it's descending down. What do you think point P represents?
The hot air balloon starting height, maybe?
So, well, here's our options. We have starting height, when the hot air balloon lands, when the hot air balloon is halfway to the ground, and when the hot air balloon is 2/3 of the way to the ground. So point P is the one down here.
Mm-hmm.
No problem.
So 9 is 9 minutes. And if we go over to the y-axis, that's 0 feet. So after 9 minutes, the hot air balloon is at 0 feet. Is that where you're starting?
No.
Where is the hot air balloon at that point?
9.
550.
Well, just like in terms of, sorry, I got out. I think there's a teacher with a recording after me. Can you still see my screen?
No.
No, it's in the way.
But I see.
Okay.
Sign in with Google.
Okay. So I didn't realize the next teacher was going to be starting so soon. So let's just wrap up this question, even though you can't see it anymore. That's where the hot air balloon landed. It no longer was in the air. At 0 feet means it's touching the ground. You're not up in the air anymore.
Right.
Okay, thanks for coming today. We'll have another session next week at the same time.
All right, thank you.
Yep.
Thanks.
Bye.
Bye.